Complex numbers. There's something about it that mucks people's brains up. And if you look at this sheet, this is the last 7 exams here in Western Australia. And every one of the green sections, and I think I've only got them in green. Look how much green's on there. The green are the questions for the last 7 years, Western Australian specialist exam papers on the topic of complex numbers and related to it. There's a lot. Now, the basics of it, people muck up. So here's what I'm doing. Teaching strategy. People haven't listened to me talk about it. Sometimes I'll teach a topic that we're not up to doing. Why? Give your brain a chance to take it in before we get serious. Okay? I wish I could get that through to a lot of teachers. Just teach something randomly. Also, we're sick of the other 2 topics we're on. Yeah? So we just change topics and hopefully it gets your brain captivated. Now, the basics of that, I said solve that equation. What do I get? If I turn a squared into not a squared, of course I'm going to get a square root. If you wanted to, you could say I get the square root of that side and I get the square root of that side. But when you turn a square into a not square, you have to remember one thing. Plus and minus. Why? Just in case a couple of people muck up on it. If we had x squared equals say 25, there's 2 possible answers. What are they?
5 and minus 5.
5 and minus 5. So over the years I've put plus and minus 5. More recently, because how much in an assessment specialist and method students forget to write plus and minus, I started writing it as 5 or minus 5 to try to get people's brain to connect. And by the way, if there's a square, we're expecting 2 answers. If there's a cube, we're expecting 3 answers. Concept-wise, for a moment, I will sidetrack for a minute. This is basically a parabola. And we're expecting a parabola can cross the x-axis in how many places? 2. And I will sidetrack a step further. A cubic can often look like that. And we're expecting the cubic to cross in how many places? 3 places. Now we're going to look at the cases though, where the parabola doesn't cross anywhere. And you can look at the case for cubics when you might do this. And that cubic only has 1 place where it crosses the x-axis. But we're going to find 2 imaginary places with a different system where it crosses another, or gives us another couple of solutions there. Now I need to get rid of that for a second. Okay, now here's the rule. Long time ago, someone said, let I squared equal minus 1. Interesting, I for imaginary. Now I could go into uses in life. I do talk to engineering mates and friends who say, yeah, they use complex numbers all the time. Not going to go there today. So I equals the square root of minus 1. Yeah? If you wanted to, you could even go plus or minus. So wherever you see a square root of minus 1, what are you allowed to write? I. So here we've got this thing here. We've got plus or minus what? Plus or minus I. Most of the time though for this, we don't look at this. We've got x squared as minus 1. You can take the square root of both sides and x is the square root of minus 1. Then we let square root of minus 1 be called I. And the solution to that is I. Let's go back to the original equation. If I had I squared, get rid of that. If I had I squared, is that minus 1? By definition, yes. Where am I going to draw that? How am I going to draw that? New set of axes. Works the same as the other ones. This is called the real part, and now we'll talk about the complex numbers being a z. Use a z from, and a lot of people put a cross across the z so it doesn't look like a 2. So I've got this one here, there's the real. I can go there's 1 and there's 2. I can go minus 1 and on we go like usual. There's 1. So this one we call the imaginary part of z. Now the imaginary part of this is just I. So by the way, we've got I plus 0. The real part is 0 and the imaginary part is I. Now I could write there I if I want to, and I could go 2i, 3i, 4i, 5i. Instead, once we define that as the imaginary part of z, that's 1 and that's 2, and on you go using it just like you'd normally use a Cartesian. But instead, it's talking about the real part and the imaginary part. So the answer to that question there is that one there. How do we know it's true? If I put I squared in, I get minus 1. if I put minus I in there, minus I squared, so if I had minus I squared, does that equal minus 1?
Yes.
Yes. So I squared. So you could muck around with having all that written there, you still get the same thing. Now's when it makes a bit more sense. Ready? How do you solve any equation that equals 0? Starts with Q, U, A,
Quadratic formula.
quadratic formula. We can't get two numbers that multiply the two that add up to minus 2. So in other words, we're not factorising with nice numbers, we've got a whole new system. So here we go. I could make it nice numbers, and this one doesn't turn out to be too bad. What's our formula, quadratic formula? Minus b plus or minus square root of.
B squared minus 2.
Let's have a look what we got. Say it for me. Grace, can you tell me what to write? Maybe pull the mask down for a second.
2.
Yep.
Plus minus
Yep.
square minus 2 squared.
Which I'm happy if you go straight to 4, because I've seen so many people write minus 4. It's ridiculous.
Minus 4 1 times 1 times 2.
2, and we doesn't hurt to write them in. And then 2 times?
1.
Yeah, so we got 2 plus and minus the square root of what? I'm going to slow down a bit here.
Minus 4.
Yes. So if you see the 4 take the 8, you can go straight to there. Now here's the big thing that people don't understand in the beginning. Alex, here, look a second, mate. I can write that as root 4 times over root minus 1. Square roots, you can multiply the insides. So what can I replace that by now? So I've got 2 plus or minus 2 root 4, and that one I can replace as I on 2. By the way, common factor through all of them. Cancel the 2's. Really, I should probably go, that's 2 outside of 1 plus or minus I. Are you okay with what I just did? Take out both the 2's, and you're left with a 1 plus or minus I. The 2's are going out the front. 2's cancel, and you're left with 1 plus or minus I. So on this one we've got 2 answers, and I'm going to write them separate. 1 plus I, or the other one is 1 minus I. So if I go over to here, let's have a look at the solutions this time. Take your time, look up. One of them is 1 plus I, so you go to 1 on the real, and you go up to I. So that one there is called 1 plus I. Where's the other one?
1 minus I.
1 minus I. So it works like a Cartesian system, but it's a whole new understanding of the real and the imaginary. Yeah, so I'm just going to write down the quadratic formula because I'm an old fusspot with that. B squared minus 4. Probably don't have to. You can do it all in your head, couldn't you?
Yeah.
Just too risky. They make too many stupid mistakes. So Finn.
X equals negative 4 plus minus the square root of 16 minus 4 times 8 times 1.
Yep. The other way around though.
Oh yeah.
Wouldn't matter, would it?
No. Over 2.
2 minus 4 plus or minus the square root of.
Oh my goodness. Oh, it's negative 16, sorry.
Yeah, so would it have been better? Now see the amount of time you spent thinking about it?
Oh.
I learned years ago, if I think too much during the assessment, I don't know, something would happen. My brain slowed down. Then I'd make silly mistakes. So you've actually got minus 4 plus or minus square root of minus 16. And we don't want the negative, so what do I do with the negative? So I can, if I want to, if you're confident enough, just write that square root of 16 is 4, and the minus will become an I. So if your brain's ready to understand that, otherwise we write minus 4 plus or minus the square root of 16 by the square root. Now some of you might still have to do that until you get more comfortable. Just remember, this is like a new language, whole new system. When you first learn a language, it's just not comfortable, so you get used to it. They've all got common factors of 2, so I could just cancel them all out. Old school, what we do? Take out the common factor of 2. But if you're comfortable, 2 in the 4th, that's minus 2 plus or minus 2y. So as long as you can cancel for all of them. So now my diagram needs a little bit more space on it. So one of my answers is minus 2 plus 2i, and the other one is minus 2 minus 2i. Can you imagine what we're going to do with this later on?
Do we really want to?
We're going to start using angles and how far is it from the centre, and the whole topic will open up. The thing is, it will save you, I'll give you incredibly quick ways of getting solutions to equations that otherwise are annoying, fiddly and time consuming. It really does work well. So I need to go up here and extend this up. So there was 1, so here's 2, that's the imaginary of Z. Now, big issue. That number is called the what?
Real.
The real part of Z, and everyone just goes RE of Z. You don't need to cross the Z if you think your Z's clear. And then, now please, what is it when I get to an assessment and I say write down the imaginary of Z, people put 2I. It's not the I, it's just the 2. Here in my brain, here are my words. It's not the 2I, it's just the. So the real of Z is -2, and the imaginary of Z is 2. And I might feel like, man, big issue, not I, like, and I do the, you haven't seen the hello for a while, have you? Have you seen me do that? And I do crazy faces. My goodness, you know, I'm tearing my hair out. Not I. So the crazier it is, hopefully it sinks in, but I can do the craziest on the planet ever on this and say, don't write I in the next assessment for imaginary for Z. Is it running? Good. So, where is it? -2 plus 2I. So I've got to go right over here to -2 and up to 2. So there's -2 plus 2I. That's one solution to that equation. And the other is -2 minus 2I. -2. Is that right? Yes, that's what happens. -2 minus 2I. Now, people will tend to do this. They'll talk about that might be Z1 and they might say that's Z2 and that can be called Z3. So if I wanted to talk of all that, about all of them, I can just give them little labels, Z5. Yeah? But we haven't got all 5 of them from one question. We've got from different ones. But if you were trying to put a lot of stuff on one diagram and save some writing, that would work. That's complex numbers.